So here's a demonstration of the noise toaster external VCO being driven by a external waveform generator. This is a Siglent SDG 1025, just a simple benchtop waveform generator, and it'll output, you know, pretty reasonable range of different kinds of waveforms. You can see it does, you know, I don't know if you can read that, square, sine wave, square, ramp, pulse, noise, and arbitrary waveforms. So we'll look at some of those. But the first thing I want to do is kind of make sure that the voltages are okay. Right now it's going 4 volts peak to peak with an offset of 0, which means it'll be you know, -2 to +2. I really don't want to put in any negative voltages into this thing because it's only a battery, and we want everything to be relative to the BN, if you will, the 0 volts of the 9-volt battery, which is basically the same as this DC power supply that's coming in at the moment. So that's a DC power supply from the wall. So everything's going to be based on that. That's basically 0 to 9. So if I switch this to high level to 2 volts, and then the low level to 0 volts, that'll be fine. So it's right now it's going 0 to 2, and it's a sine wave. So let's turn it on. We'll plug in that, and we'll turn this on. You can see the output isn't enabled at the moment, so it's doing its thing. It's got an LFO in there. Let's take that out. Actually, that's there's both envelope and LFO. So let's take that out, and let's just hear what a sine wave does to it. Right now it's at 1 kilohertz, so that's kind of crazy. Let's disable that. Let's change the frequency to 2 hertz, right? So you can hear there, that's what a 0 to 2 volt sine wave at 2 hertz is doing to the VCO input. In other words, the tuning voltage input, right? And it kind of gives you the idea that this machine, you know, could be, you know, a tunable synthesizer, if you will, right? So there's disabling that again. So let's just hear what it does with a square wave. That makes sense. Here's a ramp. So the ramp is the same as the sine, just a little bit different attack rate, linear attack rate as opposed to a sinusoidal attack rate. But what happens when I do this arbitrary? So this just happens to be the arbitrary waveform. Just happens to be this voltage staircase with, I don't know, however many steps that is. So you can kind of hear what it's doing to it, and you know, obviously everything else is still in play. It gets a little wonky when you introduce other modulations to the VCO, but that's what the arbitrary waveform generator sounds like. And let's see, if I select another waveform, so that's a stair up. What about a stair down? Well, that makes sense. And if I do this again, if I do load waveform, built-in waveform, not sure what a P pulse is. It's kind of a sync style waveform, not terribly interesting. Let's go back to the sine wave. Anyway, so just to show that you have external control over the VCO with a arbitrary waveform generator. So that's an option. You can imagine substituting this benchtop unit with an Arduino or any other, you know, embedded programmable device that can output, you know, a DAC style output. Certainly 2 hertz isn't of any challenge. If you go much higher than that, if you go, you know, we started out at 1 kilohertz, and the electronics was having a little trouble keeping up with that. So anyway, just wanted to demonstrate that. So what I wanted to demonstrate next was the optional alternative input into the voltage controlled filter, the VCF, and that's this input over here. that again is just a regular 1/8 inch mono jack. And again, I've got it hooked up to this signal generator, relatively primitive, but you know, fairly capable signal generator. The trick here is this is an alternate input into the filter, and allows you to put in your own signal that will go through the filter. So it's almost like an alternate VCO input. So we have to jack up the frequency quite a bit here to get anything kind of interesting to come out of it, because previously we were feeding in a modulation signal to the actual frequency control. This is an actual audio tone, if you will, that's going into the VCF. So let's hear what that sounds like. So it causes some interference without it being in there. So that again is the VCO by itself as a square wave. Now if we shut that off and then plug in this guy, you can hear a little bit of noise come in. And then I've got some arbitrary waveform here. I'll enable that. And right now we're at 200 hertz, and I do have frequency control over this thing. So if I put in here like 100 hertz, you can hear it change. You got to be really careful with the amplitude here. Right now I've got the amplitude going from 0 to 250 millivolts. I can bump that up to a 1/2 volt, 500 millivolts. You can hear it get much louder. You hear some noise in there as well, right? So it is, that signal is subject to the VCF controls themselves, okay? And now I can introduce the actual onboard VCO. So I'll bring that in as well, and you can kind of hear that it's sort of tuned to it at the moment. There I'm changing the frequency. So here I can introduce some perfect pitch amplitudes, if you will. I don't know what that is, a 4th or a 5th or whatever. But so there's an octave. Now I can introduce some LFO. You can hear it pulsing because it's not quite staying tuned, right? So let's introduce some modulation. So now it's singing at a 1/3. Kind of hear that effect. Let's bring this amplitude down a little bit. 250 millivolts. Quiet that down a little bit. Maybe 350 millivolts. Bring the frequency up a little bit. 250 hertz. You can hear it become synchronized with it, right? It's right on top of it. It's bouncing out a little bit. Major 3rd. Yeah, it's kind of fun. Anyway, that is the alternate VCF input, or I should say, alternate signal into the VCF. So that's the kind of fun you can have with that. But it doesn't quite stay in tune, but that's part of the fun. Anyway, I'll shut this off. And then shut off the other VCO, and now nothing going into the VCF. It's quiet now. And again, all of these demonstrations are with the speaker that's built into the actual noise twister itself. So the speaker is part of the fun. So anyway, that's that. Okay, so that kind of concludes my noise toaster build presentation. So I covered all the mechanical stuff that I did, all the kind of mods that I did. Including a switchable power jack, You know, putting the speaker in, putting the box, the alternate input to the VCO. This is really a you know, traditional control voltage CV input, and then the alternate input into the VCF, which is really an alternate VCO input, which allows you to have multiple channels going on at the same time. And I'm still figuring out that envelope generator input, so I didn't really show that. I haven't quite figured that out yet. And you know, we were able to input some of that stuff with this signal generator, which is invaluable in some of this stuff. And some of the other equipment you need, of course, is a, you know, soldering iron and some solder, and bench power supplies help, and an oscilloscope is a handy tool, so you're going to have one of those. And here's another breadboard that's going on. So Noise Toys is a great little platform to start with, and it's got a lot of things going on. It's a great way to get started in the DIY synth community. And my thanks to Ray Wilson and SynthCube for making these available and building them in the first place. Rest in peace, Ray. So along those lines, this is the next project I built, and maybe you guys will find that interesting too. This is the Music from Outer Space Sound Lab Mark II synthesizer. So this is all built up and ready for testing, and that's been going pretty well so far. So hoping to show off that at some point in time too. So anyway, that's it. Thanks for watching.